Today we're going to keep on talking about unit conversions, and in particular I want to go over some examples of doing unit conversions when the units are more complicated than just let's convert one unit into another. For example, we've been looking at cases where we need to convert, say, centimeters into meters, or maybe inches into feet, or sometimes even things like, oh, maybe we have something that's measured in yards and we want to convert it over into meters. So we kind of go through a process where we go from yards to feet to inches, and then from inches to centimeters to meters. This time I want to look more at things like, I believe we did an example kind of like this at the end of the last lecture that I posted, where we were dealing with things like, what about when you're dealing with something that's measured in multiple units? So for example, if I wanted to convert, let's say 3 square feet into square inches, this is one of the kinds of things that I'm talking about. We measure areas in square feet because, of course, an area, if you think of the area of, let's say, a rectangle, well, it's the length of the bottom times the length of the height. You know, base times height for rectangles. And if you think about what are the units going to be, well, that means it's going to be whatever the units of the base are times whatever the units of the height are. And since those are both lengths, we get length squared as our unit. Now, if we want to do a conversion like this, we can still use the conversions for lengths. We do basically the same thing. It's just we need to use the conversion twice. So let me illustrate that with this example. I want to end up with inches. Now, the conversion that I know is 12 inches per 1 foot. That's one of our conversion ratios. And so we can actually, if we want to write it as a conversion ratio, we can say this is really equal to 1. So this means I can start with my 3 feet squared, and I can get rid of one of the feet by multiplying by 12 inches over 1 foot. Now, one of those feet units will cancel, and I get 1 inch as a unit. So I get feet and inches as my units, feet times inches. I really want inches times inches. So I need to multiply by 12 inches per 1 foot again. Now, the other feet unit gets canceled out here, and I have 2 inch units that are multiplied together. And so this is going to become 3 times 12 times 12 inches squared. So this is the correct unit. All I have to do now is to figure out what this is going to be. Well, this is going to be, let's see, 144 times 3 is 432, I believe. So it would be 144, then 288. $432. Just making sure that I actually did all of that arithmetic correctly in my head, so I wanted to double check myself before I wrote it down. Obviously, if you have a calculator, you can easily throw it into there and do it without having to do it in your head, but I wanted to do it this way, since I don't have a calculator. And of course, this is going to work with any other kind of thing that we want to deal with as well when we're dealing with areas. Now, you could also have a situation where you need to deal with volumes, maybe. And the same kind of idea is going to work for you here, okay? So, let's say that I want to convert, suppose that I want to convert 4 cubic meters to cubic centimeters. In other words, meters cubed to centimeters cubed. Now, volumes are length times length times length. So, yeah, they really are some unit of length cubed. Now, if I want to go from meters to centimeters, then the conversion ratio that I know is that there are 100 centimeters per 1 meter. So if I start with 4 cubic meters. In order to get rid of a unit of meter, I have to multiply by 100 centimeters per 1 meter. That gets rid of one of my meters, but it leaves me with meters squared and centimeters. So I'm going to multiply by 100 centimeters per 1 meter again. That gets rid of the squared meter, and it leaves me with centimeters times centimeters, or centimeters squared. I still have 1 meter left, so I have to do this a third time. And that will get rid of my last meter unit, and it leaves me with 3 centimeters. So I end up with 4 times 100 times 100 times 100 cubic centimeters. And the nice thing about this, of course, is that this is one of the things that makes working in the metric system kind of convenient for a lot of applications. Well, this is a very easy thing to multiply because all of these are powers of 10. So this is going to become 400,000 cubic centimeters, which is, of course, 4 million cubic centimeters. By the way, this is where kind of that scientific notation stuff that we've talked about can be useful for writing things down. It might be easier to write this as 4 times 10 to the 6th cubic centimeters if you wanted to. You could do it in scientific notation. I don't care. I mean, write it however you want. This is fine. This is also fine, as long as you get the correct answer. Now, one thing that I want to observe about this is you could actually kind of take, this conversion ratio and you could make it into a conversion ratio for meters cubed right off the bat if you wanted to. So instead of going through this process where I multiply by the same conversion ratio over and over again, I could say, well, if this ratio is equal to 1, then that means that 100 centimeters over 1 meter cubed is equal to 1 cubed. So this is still going to be some kind of a conversion ratio. But when I cube this, I get 100 cubed centimeters cubed per 1 cubed meters cubed. And that, of course, is just going to be 10 to the 6th cubic centimeters divided by 1 cubic meter. So this is another conversion ratio that works for volumes. In other words, I can work out this one conversion ratio for volumes and just use this instead because I know this conversion ratio for lengths. Whichever way you want to do it is up to you, but really the reason that you want to just remember the ones for lengths is because you can always just use those or use those to get a conversion for volumes, and that way there's less to have to memorize, okay? So as long as you remember how you do this, how you do the problem, and you memorize the conversions for lengths, that's going to be kind of an easier, more straightforward kind of thing to do. Now, some things are actually measured in more complicated units. So an example of this would be speed. Speeds are distance divided by time. And this makes them a little bit more complicated than this kind of things that we've worked with before. So how would we deal with converting between different ways of measuring speeds or whatever we happen to be dealing with here? For example, let's suppose that we want to convert let's say 360 meters per second to meters per hour. Well, this is going to be a little bit different than what we've done before, although we're going to get there in the same idea. So what we want to do is we want to cancel out the seconds, which are in the denominator, and end up with hours in the denominator. Now, the thing that we know is this. We know that there are 60 seconds per 1 minute, and we also know that there are 60 minutes per 1 hour. Sorry, I should write this as M-I-N, not M, so that you don't confuse it with meters. There are 60 minutes per 1 hour. And so this gives me 3,600 seconds per 1 hour. Now, the thing that I can do then is if I want to get rid of seconds that are in the denominator and end up with hours in the denominator, I can multiply by this ratio. It has seconds in the numerator. Those will cancel out the seconds in the denominator, and it gives me hours in the denominator. So, 360 meters per second times 3,600 divided by seconds divided by 1 hour. The seconds are going to cancel, and we are left with meters in the numerator and hours in the denominator. So this is going to become 360 times 3,600 meters per hour. Sorry, I wrote down the wrong units there for a moment. And I will leave it to you guys to figure out what this exactly comes out to be. You can throw that into a calculator and get the answer for yourselves. You could alternately, instead of doing this, we could have said, okay, let's just multiply by each of these things separately. So we could have said, okay, let's take 360 meters per second times 60 seconds per minute times 60 minutes per hour, and then the seconds would have canceled and the minutes would have canceled, and we would have gotten 360 times 60 times 60, but we still would have had meters per hour, and it's not too difficult to see. Well, 60 times 60 is 3,600, so these two things here, these are actually equal to each other. So both ways of doing this give me the correct thing. The new thing, the thing that we kind of haven't really seen before, is that instead of trying to change just a unit that's on here, I'm now trying to change a unit that's in the denominator. But as you can see, it's the same idea in that I'm still just trying to cancel out the unit that I don't want and end up with the unit that I do want. It's just that it happens to be in the denominator this time. The same thing is going to work if we want to do a different kind of conversion with speeds. So let's suppose that I want to convert let's say that I want to convert 120 feet per minute to yards per second. So this time, I want to convert my speed units, and I don't want to just convert the time. I want to convert both the distance unit and the time unit. Well, in order to do that, I need to convert, basically, I need to use the conversion from feet to yards, and I also need to use the conversion involving minutes and seconds. Now, take a minute here, pause the video, and see if you can work this out for yourselves. And now we're back. I will show you guys how you can think through this. So the first thing I want to remember is that 1 yard is equal to 3 feet. So if I want to cancel out feet here from the numerator and get yards, I want to say I'm going to need to multiply by 1 equals 1 yard over 3 feet. The other thing that we know is that 60 seconds is equal to 1 minute. And I want to cancel minutes from the denominator and to get seconds in the denominator. That means I want minutes in the numerator and seconds in the denominator. So the conversion ratio I want is 1 minute, that is not how you spell minute, 1 minute per 60 seconds. So we have 120 feet per minute. I need to multiply by yards per feet to change the feet into yards. So that's going to multiply by 1 yard per 3 feet. That cancels out the feet and it gives me yards. And in fact, if I just left things like this, I would have yards per minute, which is a perfectly valid way of measuring speeds. It's just not the way that we want to measure them here. So now I need to multiply by this conversion ratio so that I can get rid of the minutes in the denominator and replace them with seconds. So let's multiply by 1 minute divided by 60 seconds. The minutes are going to cancel here. And this is going to leave me with 120 divided by 3 times 60 yards per second. Well, this simplifies a bit. I can divide the 3 into the 120, and I get 40 over 60 yards per second. But that I can simplify further into 2 over 3 yards per second. So we end up with 2/3 of a yard per second as our speed. All right, so hopefully this makes sense. Basically, anytime you approach one of these kinds of problems, you are going to be trying to just take whatever units you have and find what conversion ratios can we multiply by that get rid of the units we have and end up with the units that we want. Now, sometimes you have to do kind of a sequence of these, a chain of these, as we've done before, but it's the same kind of idea every time. Let's take a look at a slightly different example. Another kind of unit conversion that can be kind of common in some applications is when we think about pressure. Now, pressure can be thought of in some contexts as a weight per area. So, for example, we could have a situation where we want to convert, let's say, 30 pounds per square inch to ounces per square foot. Now, I'm not sure that there's anybody who actually wants to measure pressures in ounces per square foot, but we might want to for some reason, so let's check this out just as an example to see how you would do it. So the conversions that we want to remember are, we need something relating ounces and pounds. Now, hopefully you guys remember 16 ounces is equal to 1 pound. I want to cancel pounds out of the numerator, so I need pounds to be in the denominator. That's going to give me the conversion ratio 16 ounces per 1 pound. Now, I'm going to want to cancel out the inches in the denominator and end up with feet in the denominator. The relation that I want to remember is that 12 inches equals 1 foot. And that is going to give me the conversion ratio of 12 inches per 1 foot. So, since inches are in the numerator in this ratio, they can cancel the inches that are in the denominator. So we get 30 pounds per square inch times, I can multiply by the 16 ounces per pound to get ounces. So this is going to be 16 ounces divided by 1 pound. And then I want to multiply by 12 inches per 1 foot, since I've already canceled out my pounds. That's going to cancel one of these inches here. I need to multiply by another 12 inches per 1 foot to cancel out the remaining copy of the inches units that are in the denominator. Now, In the numerator, I have ounces, and in the denominator, I have feet times feet, or square feet. So this gets me 30 times 16 times 12 times 12. In the denominator, I actually, in this case, just have 1 times 1 times 1. And the units that I've ended up with are going to be in ounces per square feet. So at this point, I will leave it to you guys to enter this number into a calculator and see what you get. I don't feel like doing that in my head, but you can simplify this down, and we have this in ounces per square foot. So all of these types of conversion problems, they go very similarly. Okay, so let's just very quickly review the basic process of what you want to do. And essentially what it comes down to is this. You ask yourself this question: how do we cancel the original units and replace these original units with the new units that we want to have there? So in the last example, we didn't want to have pounds, we wanted ounces. We wanted to cancel out pounds and end up with ounces. We also wanted to cancel out the square inches in the denominator and get square feet in the denominator. So we asked ourselves, what conversion ratios that would we need to use? Okay, I just wrote rations instead of ratios. Anyway, we asked ourselves, what conversion ratios would we need to use? And remember, a conversion ratio is a fraction involving units that is equal to 1. So something like 12 inches per 1 foot. Those are actually the same quantities, so their ratio is equal to 1. And the thing about conversion ratios is that multiplying by a conversion ratio is like multiplying by 1. It doesn't change the value of whatever you're multiplying. It leaves the value the same. It just rewrites it using a different unit. So that's why we can use these. So you really just have to ask, what conversion ratios have the correct units to cancel? So we want to use not just conversion ratios, but conversion ratios with appropriate units. Now, what we're going to start looking at next is how you can use these same kinds of ideas for other types of problems that involve things like computing doses for patients, whether they are animal patients, human patients, whatever we're talking about here. This kind of idea where you think about making sure that all the units are appropriate, this is sometimes called dimensional analysis. And the vet department likes to call this dimensional analysis in the handout that they gave me. Really, what does that dimensional analysis mean? It's just a fancy word for saying make sure that all of your units are the appropriate units. So later this week, we will start in on talking about that kind of dose computation thing. In the meantime, keep practicing your conversion problems, and I will talk to you guys again soon.